Okay, yesterday we talked about a certain word. What was that word, everybody?
Decomposing.
And we kind of thought about it like an apartment complex or some townhomes. And we have certain numbers, and this is the address. This is where each of these people live. Okay, one person lives in 100, one person lives in 10. That's their address. And let's say we have a number. Raise your hand if you can read that number to me. We shouldn't have our hands on anything at all right now. Because if our hands are on something, that means we're probably looking at it. And we're not paying attention.
54 and 36 hundredths and 8 thousandths.
Okay, remember one strategy you can use when reading decimals? Just cover up the number in front of the decimal. And how would you just read that number by itself? How would you just read this number by itself? Oop. Just play that number is all by itself. How would you read that? Huh?
368.
368, right? But it's not by itself. It's in this chart. So you read it just like you would if it's all by itself. So read it just like you would if it's all by itself.
368.
68. And what is the place the last number is in?
Thousandths.
Thousandths. So now read the number to me.
54 and 368 thousandths.
Woohoo! Nice. Give yourself a pat on the back. Good job. Well, we have these numbers. I'm going to make it a little more challenging because someone needs to move into 100, right? It's empty. And the landlord wants more money, so we're going to put, let's go for a 1. Okay, all units are now filled up. No more vacancies. Well, guess what? One day, the manager comes in and he knocks on apartment 100. And he says, "Excuse me, your apartment is decomposing. We've run a whole lot of tests and it is about to exist no more. You have to move out. You can move." Anyone know where it's going to have to move? To 10. You can move next door. Person in apartment 10 said, you can come live with me. That's fine. Okay, so now we have 2 people living in 10 together, right? But what's happening to 100? It's going to just stay there because it's like decomposing, remember? Slowly decomposing. The next day, the manager went to the next apartment over. And he said, "Oh my goodness, it's spreading. It's now going into the next apartment. I have to move them out. You can't live here anymore. It's," everybody?
Decomposing.
So what do you think those 2 people did?
They moved into the one's place.
They moved next door. Now, how many people do we have living in this place? 3. Are they still the same people, though? Yeah, they're still the same, aren't they? They didn't change in size, did they?
No.
They're the same size. Well, they may be eating more now. I don't know. they're the same people, right? They haven't changed. They were the same people as they were on day one. They're the same people as they were on day two, and they're still the same. They just live in a different place, don't they? But they're still the same, aren't they? So, you're never going to believe this. I would never rent from this guy. What do you think happened on day 4? Oh my goodness. Day 4.
They had to move to the 110's place because the decomposing it kept spreading all the way to the 1 place.
Yes, it was spreading. Oh my goodness. And not only now were they having to move next door, but they were having to go across the alley to the next building over. But surely, since the two buildings are separated, it won't spread, right? I don't know. We'll see. Now, how many people are living in the 110th apartment?
4.
4. Are they the same people?
Yes.
Are they the same size?
Yes.
Yeah. They're not going to grow that much in a day or two, are they? I mean, give it a year or two, they might be wearing different size clothes. I don't know, but they're not growing in a day or two. Well, the unbelievable happened. Oh my goodness. It was a knock that 3 of them were familiar with because they had heard it every day for the past week. What's the manager going to say?
Your apartment is decomposing. You have to move next door to the 100.
Your apartment is, everybody?
Decomposing.
Move
Out.
and move.
Next door.
Now the problem with the apartments with the red roof is they're smaller spaces because they're not really a full apartment. So now we have all these people squeezed into one. Are they the same people?
Yes.
Are they the same size?
Yes.
They just live in a different
Apartment.
or a place, right? Well, this is starting to kind of remind me of the 3 Little Pigs, right? Because then we go one more day. And the manager comes and he knocks and he knocks. He doesn't huff and he puff or anything. Maybe that's why the other buildings were decomposing. Maybe the wolf's been out all night blowing on them. I don't know. So everybody, what's the manager say? Your apartment is?
Decomposing.
Move!
Out.
Move!
Next door. Wait, there is no next door. There is no next door. Yes, there is. Yeah, there is. Right there. Oh.
So,
I wonder what happens.
is this number the same number as this one?
Yep.
Remember, same people, just different place. Is this the same as the other 2?
Yep.
I can't stand at an angle and draw. Sorry, people over here. How about this? It's so far over. Is it the same?
Yep.
So you mean to tell me that every single row, that's the same exact number, but it's written differently, huh?
Yep.
Yeah. What's that called when you do this?
Decomposing.
That did not sound like you believe it. Everybody, come on.
Decomposing.
Woo! I hope people turn down their speakers for that one. Well, today we're going to take it one step further. We're going to start with this number. Raise your hand if you can read that number to me. 3 1/10. So I have the number 3 1/10. And I want to decompose that number. How would I do that? How would I do that?
You bring the 3 into the 1/10 place.
Okay, you bring the 3 over to 1/10. And now we have 31 tenths, right? Now there's a way you could write it. You could say 31 . Or you could make it look like a fraction. What would that fraction look like?
Probably 1/3.
1/3? 31 tenths. No, what do you think? Okay, you could have 31 on top and 10 on the bottom. I don't know, I've been trying to figure out an easier way to do this so we don't have to write out the words because there's really not enough space, and I tried abbreviations in my answer key, but I think I'm going to try to take it from a fraction perspective. Maybe. We'll see though. We'll see. Because if the number's over 10, which column is it going to be from? Tenths. If the number's over 100, which column is it from? And if it's over 1,000, what number is it from? So, if when I'm done teaching this, if you feel comfortable with writing whatever number's in this box over that number, or whatever number's in this box over that number, you can do that. Because, you know, some of us, if our handwriting's really big, you're not going to have much space. Because I can't even hardly read what I wrote. Granted, I have terrible handwriting, but I mean, I've been slaving over this all morning trying to make it fit on this page, so we'll see. So tell me this one, guys. Give me a thumbs up if you think those are the same numbers. Give me a thumbs down if you think that they're different. So you mean to tell me that I can add as many zeros as I want to the front of a number and it won't change it at all? Okay, well, let's see if I can stump you on this then. I don't want to do that. Let's do it this way. So is this number the same as that number? So you mean I can add a bunch of zeros to the front and it won't make a difference, but I can't add them to the back? Because my number went from 31 to what? Who can read that number?
31,000.
Let's do it that way.
310,000.
So is 310,000 the same as 31? What is that invisible thing behind every single number? It's like the equator that goes around the earth. It's there, but you can't see it. It's like air. It's there, but you can't see it. What is that invisible thing at the end of every number? A decimal. Well, let's say we put, instead of a whole bunch of zeros, what would happen if we put a decimal first? Now, are those two numbers the same? Are those three numbers the same? Give me a thumbs up if you think those three numbers are the same. If you don't think they're all three the same, show me with your fingers how many you think are the same. Actually, they're all the same. If you have a decimal, you can add as many zeros behind it as you want. If you have a regular number, you can add as many zeros in front of it as you want. And you need to know that because that's important for what you are about to learn about rounding. On your first problem set today, you don't need to look at it right now. It says round to the hundredths place. Right here. What number is in that place? There's nothing there, right? But we can add a zero. So then when we break down our number, it'd be like this, wouldn't it? When we decompose it, will it look like this? Did I do it? I didn't do that, right? Forgive me, people. There we go. That's not right. I don't need that. I get myself confused sometimes. Okay. So we're looking at hundredths. Everybody, how many hundredths do we have right now? Total. How many total hundredths do we have? Everybody.
310.
310.
100.
Whoa. Okay. Let's try that one again. Everybody. How many hundreds?
10,000.
Okay. We'll try that one more time. How many hundredths do I have?
310 hundredths.
So that it says to round to the hundredths place. So, and I'm not sure why they say to put the big number on bottom, and I'm not doing that. I'm doing it the way I feel is the right way. So you need to make sure you're paying close attention because pretty soon we're going to be clicking in the answers. And we're going to expect you to know how to do this. So, this is our starting number, right? 310. Because they say round to the hundredths place. So I'm going to start with the number 310. 310 hundredths. What's the next number after 310? What's the number after it?
2,100.
If I just have the number 310 all by itself, what would it be? What would be the next number? If you're counting up, 309, 310, 311. $311 Now, yesterday in my class, we talked about the fact that when you go from one place to another, you're going up 10 every time, right? But what if you want to go halfway between that? What's half of 10? 5. So we have our hero who's 10 and its little kid who's 5. So you start with your bottom number, which is 310 hundredths. So how many thousandths do you think I might have after that? My class, you need to pay close attention because this is all new. 5 thousandths. Because I'm not completely to the hundredths place yet, am I? I'm only halfway there. 5 thousandths. So let's look back at our place value chart where we have decomposed numbers. I have 310, right? But now it says I need at least 5 thousandths. How many thousandths do I have next to my 310? 0. Would this be the same as 310 and 0 thousandths right here?
Yeah.
So if I were to round 3 1/10 to the hundredths place, I would end up with 310 hundredths. Okay, let's try another number. And I'm going to decompose it. I'm going to decompose it rather quickly so that we can get to the rounding part. I think you guys all pretty much understand the decomposing part. Okay. This time it says we're going to try rounding to the hundredths again. So I'm going to go directly to my bottom number, which means I have 11,537. Everybody? 11,537. There we go. That's better. Raise your hand if you can tell me what number is going to go on the bottom of that vertical line graph that we have there. What number is going to go at the bottom? 11,537. But we don't know what it is, so we're going to call it a hundredths. What number is going to go on top? 11,538 hundredths. And then we have this one, this poor little guy. Yeah, this little one, he tried to help 11,537 to get all the way up to the next level up, but he only got halfway there, so how much is he worth? 5 thousandths. This is a number we're looking at, right? Well, we already know we have 11,537. But now we have to look at this right here to see if it's going to move us up any. The thousandths place. Show me with your fingers. Everybody, what number is in the thousandths place right now that we're going to look at? Everybody, show me with your fingers. What number is it that you're going to look at? I don't see everybody's fingers up. Show me with your fingers. What number is in the thousandths place right next to the one I just circled? Good. 6. So if I were to look at this whole line where my hundredths place ends, I would see that I have 11,537 thousands and hundreds and 6,000s. Would that go above or below that number?
Yes, it would go above just slightly.
Just slightly above? Why would it go above? Why do you think?
Because the thousands, 6 in the thousands is bigger than the 5 in the thousands.
Good, because remember you learned this week that 6 is greater than 5, in case you didn't know that in previous years. If I have 6 things, I have more than you. Sorry, if you only have 5. So it would go right here, wouldn't it? And 6 thousandths. So here's my question. Is it over the little guy who only got halfway up, or is it below that little guy who only got halfway up? Did it get up further than the guy that could only go up halfway?
Got higher.
Yeah, he made it a little higher, didn't he? He's a little higher than this guy, right? So that means he's a lot closer to the finish line than this guy is, right? If he was below, he would have to probably go back to start. His coach would be like, you go back to start, sweetheart. That's messed up. You need to go a little higher. That guy just about made it. So, Rachel, if you can tell me what 11,537 hundredths and 6 thousandths is rounded to the hundredths place. 11,538 hundredths. Because even though he didn't make it up all the way to 11,538, he did almost make it, so the coach let him go the rest of the way for best effort, right?